All right, Math 2, we are going to start on section 8.2, which is area of circles and sectors. It's on page 477. Again, we just have quite a few formulas going on in here. Of course, you should know down at the bottom, we're going to talk about the area of a circle, which is pi r squared. You should know that. And when you label this, it's always units squared. When you are dealing with area, you have to use the radius. On the circumference, you had the choice between the diameter and the radius. On this one, you have to, the formula has to use the radius. So if you are given the diameter, you do have to take half of it in order to get the radius. All right, so let's take a look here. We have the area of a circular wrestling region, and it has a 42-foot diameter. So what you're going to do is take half of the diameter to get the radius. So the radius is 21 feet. You're going to go to your formula, and you're going to input area equals pi r squared. Let's see, this one really doesn't give us any indication of how it wants the completed answer. So let's go ahead and do it, leave it in terms of pi and also to the nearest, let's do 1/10 of a foot. So do 21 squared times pi in your calculator, and you should get 1,385.4 feet squared, because it's area. And if you would leave this in terms of pi, you would literally just take 21 squared, which is 441, and you would do 441 pi feet squared. All right, so both of these can be legitimate answers depending on how they want your finished completion on there. All right, so right here, find the area of the circle, leave your answer in terms of pi. So again, it is giving us the diameter. So if you take half of 2/3, you get 1/3. So formula is pi radius squared. When you square a third, you just square the top number and square the bottom number. So you get 1/9. So you get 1/9 pi inches squared for your area on that. Okay, here, how much land is covered with an irrigation arm? All right, an irrigation arm, I don't know if you know what it is. It's a little thing that kind of comes out and water drips out of this. And what it does, it's on wheels and it goes around in a circular motion like that. So the radius is your, the length of the irrigation arm. So that is 300 feet, and it just rotates around in circles. So you're going to go and we're going to do pi 300 squared. And this one, again, since it's a word problem, I generally go to the like nearest 10th or whatever like that. So I am going to go to my calculator and type in a pi, and we're going to get 28273.3 feet squared. All right, so that's how much, how many square feet that is. And I guess it doesn't ask anything different. If you want to know how many acres that is, you can convert feet to acres. I think there's like, I don't know, 40,000 some square feet per acre. You could always divide that in and it will tell you how many acres that irrigation arm is actually covering, because acres are a little more relevant to a farmer. Okay, coming up here, just like we did last time when we had the length of a sector, this time we're going to be dealing with the area. All right, before we were just talking like about a length of an arc right here. Well, this time we're going to be talking about an area of a sector. A sector is a piece of the circle. It's like the piece of the pie. So it's this whole shaded in area is a sector. So basically just the same idea as we did last section. To get the length was a portion of the circumference. A sector is a portion of the area. So the formulas look very similar. You're going to use your degree out of 360 to get the percentage of the circle you're using, and then you'll use your area formula pi r squared. All right, so it says here a circle has a radius of 4. What is the area of a sector that is bound by a 45-degree minor arc? So the 45 will go up on top with that arc. So you'll take 45 out of 360 times, and we're given our radius, so you're going to do pi r squared. All right, and it asks us to leave it in terms of pi, so just do 45 ABC 360, and then multiply that times your 16 over here, or your 4 squared. Okay, and you get 2. So it's 2 pi inches squared. So that sector Okay, and the reason why is this simplifies down into 1/8. Okay, 45 out of 360 is an eighth, and an eighth of 16 is 2. Okay, all right, let's take a look at this one over here. We want to find the area again of this sector. So the arc is 30 degrees. So you will do 30 out of 360 times pi, the radius is 12. So we do 12 squared. Again, you can simplify this down to 1/12 or whatever you want to do, or just leave it. Take 30 ABC 360 times 12 squared, and you get 12. So it is 12 pi inches squared will be the area of that sector. Okay, here you're going to do the same idea. You're just going to have to use your radius of 8 on that one. Okay, the next thing you're going to be doing over here is we are going to find little pieces of portions of a circle that aren't really a sector, and they're not the whole circle either. So we just need to figure out how are we going to do something like that. So if you take a look here, you're going to be doing areas of triangles, subtracting things away. So if you take the area of a sector, you subtract away the area of the triangle, what you're left with is this little bit right here. They kind of show you, you're left with this bit. So on the picture up here, what it's saying is I can find this sector, which will be the whole thing. All right, but then if I take away this triangle I'm drawing in right here, I will be left with that little sliver up here. Now the formula for a triangle, which I don't know, I don't see that. You may know or may not know. It is 1/2 base times height. All right, and the base and the height have to be at a 90-degree angle. All right, so what you would do on a triangle like this is you need to drop this down to a 90-degree angle. This would be the whole base, and this would be your height of the triangle. If it's already at a 90-degree angle, then, you know, like if you had a right triangle, then your base and your height are right here. That would be your height, this would be your base. All right, but on this one, this whole length down here would be your base, and this right here would be your height. Okay, so let's just go through down on number 5. And so what we're going to do is find the area of the sector. Then we're going to turn around and find the area of the triangle. We're going to subtract them to get the area of this blue sliver. All right, so let's do the sector first. All right, so to find the area of the sector, we need the degree. So it's 120. We do 120 out of 360 times pi r squared. All right, I'm going to go and I'm going to... they're going to want the answer to the nearest tenth. So I'm going to make these to the nearest hundredth, and then in the end round it to the nearest tenth. So do 120 ABC 360 times pi, because we went around that, and then times 36, which is 6 squared. And I get, I guess it's 37.70. So 37.70, and I'll label things in the end. All right, now we need to find the area of this triangle, and this is where things get a little bit more tricky. All right, so I'm going to take this triangle and draw it out. Here's my center, and I know this is 120 degrees up here at the top. All right, if that's 120, this is 120. I'm going to drop this down to get my height, and that's going to split that into a 60, 30, 90 triangle. All right, so here's my radius right here. So this is 6, this is 6. That means my hypotenuse is 6. All right, and if that is 6, then my short leg right here has to be 3, and this length down here has to be 6 square root of 3, which means this is 6 square root of 3, which means this whole thing is 12 square root of 3. So this length right here is 12 square root of 3. My height, which I've just dropped down right here, is 3. So my formula for the triangle, for area of the triangle, is 1/2 12 square root of 3, that's your base, times your height, which is 3. Half of 12 is 6. 6 times 3 is 18, so take 18 times the square root of 3, and I'm going to round that to 37.18, or 31.18. And then what I'm going to do is subtract these two numbers. So take 37.7 and subtract 31.18, and we get 6.52 centimeters squared for that sliver. All right, this one would be a little bit easier. because your triangles are right triangle, which means your base and height are both 8 and 8. You don't need to do your 30, 60, 90 triangle off on the side. Your base and height are right here, so you just take 1/2 8 times 8 to get the area of that triangle. The area of the sector would be 90 over 360. You know, your pi times 8 squared, and you subtract those. All right. I don't know if this is going to happen at all, but let's just say this is a whole sector, so you don't have to find the area of the triangle. But if you were to find the area of this triangle and there really was a 75-degree angle up here, you're going to have to use your sine, cosine, and tangent to find your base and height. All right, but this is just a sector, so you just take 75 over 360 times pi 9 squared. This one this is going to be very similar to the one I did over on number 5. This is 120, drop that down. You're going to cut it into 60, 30, 90 to get your height, get that length. It shouldn't be too big of a problem. If you look at some of the problems over here, they're just the reverse. So what you're going to do here is find the whole area of the circle. Well, you probably just, a couple ways you can do it, I guess. You could find the area of this sector right here without the triangle, and then find the area of the triangle and add it together. This one, you need to find the area of the square, subtract away the area of the circle. This one's very similar to that one. If you want to, you can find the area of this big sector right here. So if this is 120 degrees and the rest of it is 240, so you can do 240 over 360 just to get the sector, then do the triangle and add them together. Or you can find the area of the whole circle, subtract away like we found for this one, and then subtract that out. Here we have a full circle if you put those together. So again, it's just the area of the square and subtract the circle. This one again, if you want to find the area of this sector, then the area of the triangle, add it together. Here, this piece, this piece, this piece, and this piece all put together would create a circle. All right, so again, you're just taking the area of the square minus that full circle, and you're going to get the shaded area. Over here, like if you wanted to find, I don't know what the question is asking, but if I wanted to find this hollow area, or if I wanted to find, you know, how much area is in this bolt, you find the area of this whole hexagon, which we did last section, and you subtract away the area of the circle, and what you'd be left with is this outside ring of the bolt. So just, you know, go through your knowledge. You're going to have to recall a few things that you learned before in the, you know, previously. So this is not an easy section. Just take your time and let me know if you have any questions.